The ozone layer is a region of Earth's stratosphere that absorbs most of the sun's ultraviolet radiation. It protects us from the harmful effects of UV rays, such as skin cancer and other health problems. Unfortunately, human activity has led to the depletion of the ozone layer. This has created ozone holes in various parts of the world. These holes allow more UV rays to reach the Earth's surface, which can harm humans, animals, and plant life. In this video, we will look at the causes of ozone holes and how they affect the environment and people's health. We will also discuss what can be done to mitigate these effects and protect the ozone layer for future generations. Since the late 1970s, two related things have been seen. The total amount of ozone in the Earth's atmosphere has been going down by about 4% every year, and the amount of ozone in the stratosphere, the ozone layer, around the Earth's polar region goes down more in the spring. The ozone hole is the name given to the latter phenomenon. In addition to these stratospheric events, there are also springtime polar tropospheric ozone depletion events. In today's video, we will discuss the disastrous effects of ozone holes. Before we continue, kindly click the like button and subscribe to this channel for more content. To get alerts for new videos, click the bell symbol. Have you completed this already? Let us begin. The majority of the UV light from the sun is absorbed by the Earth's stratosphere's ozone layer, also known as the ozone shield. Compared to other areas of the atmosphere, it has a high concentration of ozone, O3, yet it is still relatively low compared to other gases in the stratosphere. The average ozone concentration in the Earth's atmosphere is about 0.3 parts per million, whereas the ozone layer has a concentration of fewer than 10 parts per million. Although its thickness varies seasonally and geographically, the ozone layer is primarily located in the lower stratosphere, from about 15 to 35 kilometers, 9 to 22 miles above Earth. Charles Fabry and Henri Buisson, two French physicists, discovered the ozone layer in 1913. Measurements of the sun revealed that, aside from the absence of radiation below a wavelength of about 310 nanometers at the ultraviolet end of the spectrum, it was concluded that something in the atmosphere was taking in the missing radiation. Finally, only one known molecule, ozone, could fit the spectrum of the missing radiation. The British meteorologist, G.M.B. Dobson, studied its features in depth and created the Dobson meter, a straightforward spectrophotometer that could measure stratosphere ozone from the ground. Dobson built an international network of ozone monitoring stations between 1928 and 1958. Which is still in use today. In his honor, the Dobson unit, a practical unit for measuring the amount of ozone in the atmosphere, was created. The sun's medium frequency UV light, which has a wavelength between 200 and 315 nanometers, is absorbed by the ozone layer between 97 and 99%. Without it, unprotected life forms close to the surface could be harmed. The ozone layer. Ozone is naturally formed in the stratosphere by UV radiation reacting with oxygen. However, ozone-depleting substances, ODS, which are compounds produced by humans and include methyl bromide, carbon tetrachloride, halogens, chlorofluorocarbons, CFCs, hydrochlorofluorocarbons, HCFCs, and methylchloroform, have been slowly destroying this good ozone. The use of these compounds in coolants, foaming agents, fire extinguishers, solvents, insecticides, and aerosol propellants has historically existed, and it still does occasionally. These ozone-depleting chemicals decay very slowly after being discharged into the atmosphere. They can stay there for years as they ascend through the troposphere and enter the stratosphere. There, the UV rays from the sun break them down, releasing chlorine and bromine molecules that deplete the good ozone. One chlorine atom is thought to be capable of destroying 100,000 molecules of good ozone. Even though many ozone-depleting compounds are no longer used, their historical use can still impact the ozone layer's protective layer. According to research, there is a global decline in the good ozone layer's depletion. Satellite observations allow for the detection of ozone layer thinning, notably over the polar regions. The ozone hole. The ozone layer thinning in the high atmosphere stratosphere above Earth's poles is called an ozone hole. The solar radiation now reaching the Earth's surface harms people, plants, and animals that live below the ozone hole, causing everything from eye damage to skin cancer. Ozone is continuously created in the stratosphere by the sun's UV energy reacting with oxygen molecules, known as photochemical reactions. Even though ozone is primarily produced at tropical latitudes, ozone is transported toward the poles, where its concentration increases by large-scale air circulation patterns in the lower stratosphere. The ozone layer in the lower stratosphere was shown to be depleted in the 1980s, with an exceptionally spectacular loss of ozone known as the ozone hole in the Antarctic spring, September and October. Researchers also found that rising levels of the ozone-depleting chemical chlorofluorocarbons, or CFCs, were to blame for the thinning of the ozone layer. Causes of the ozone hole. Since before the 1980s, human activities have considerably impacted the global concentration and distribution of stratospheric ozone. Additionally, researchers have found that from at least 1980, there were significant annual drops in the average ozone concentrations. Total integrated column levels of ozone, or the number of ozone molecules occurring per square meter in sampled columns of air, decreased globally by about 5% between 1970 and the mid-1990s, with little change afterward, according to measurements from satellites, aircraft, ground-based sensors, and other instruments. The most significant reductions in ozone occurred at high latitudes near the poles, while the minor reductions occurred at low latitudes, the tropics. According to atmospheric observations, the amount of UV radiation that reached the Earth's surface grew as the ozone layer deteriorated. How does ozone depletion impact the environment and human health? Increased UV radiation reaching Earth due to ozone depletion may increase the incidence of skin cancer, cataracts, and immune system impairment. The most lethal form of skin cancer, melanoma, is thought to be on the rise due to excessive UV exposure. The likelihood of getting melanoma has more than doubled since 1990. Additionally, UV can harm delicate crops like soybeans and lower agricultural output. According to some scientists, UV radiation is already stressing marine phytoplankton, the foundation of the ocean food chain. The human food supply from the oceans may suffer due to this stress. Global initiatives to stop ozone depletion. The 1987 Montreal Protocol, a convention that gradually phased out the production of ozone-depleting chemicals, resulted from the global realization of the destructive potential of CFCs. According to scientists, human-caused rather than natural sources account for around 80% of the chlorine and bromine, which has a similar ozone-depleting impact. In the stratosphere over Antarctica today. Under the Kigali Amendment to the Montreal Protocol, it was decided to cut the production and use of hydrofluorocarbons, HFCs, by about 80 to 85% from their respective baselines until 2045. 1. Although hydrochlorofluorocarbons are potent greenhouse gases, they cannot destroy ozone. 2. This slowing is expected to reduce the average global temperature rise to 0.5 degrees Celsius by 2100. Way ahead. 1. Everyone should take action to stop the ozone layer from being destroyed. 2. Instead of using pesticides, one should switch to natural alternatives to eliminate pests. 3. Cars produce a lot of greenhouse gases which contribute to ozone depletion and global warming. As a result, driving should be avoided whenever feasible. The majority of cleaning supplies contain substances that harm the ozone layer. Instead, we ought to use environmentally friendly goods. 4. Keep air conditioners in good working order because CFCs escape into the atmosphere when they break down. We have seen the disastrous effects of ozone holes firsthand and must take action to prevent further damage. The good news is that there are steps we can take to lessen ozone depletion. We can make a significant difference in the fight against ozone holes by implementing tiny adjustments in our daily lives. Today's video has come to an end. Remember to subscribe to the channel and give this video a thumbs up if you want to see more. Remember to click the bell icon to get alerts when new videos are posted.